1944, a German workshop behind the lines, where captured enemy equipment is taken apart and studied. A German engineer has two American tanks in front of him, two Shermans, knocked out, dragged in for examination, and he is about to notice something that quietly unsettles him more than any single feature of the enemy machine. If you were that engineer, you were a product of the finest engineering tradition in the world, and you approached a captured tank the way a physician approaches a body, looking for the quality of the work, the precision of the fit, the ingenuity of the design. And by those measures, you had already formed your opinion of the Sherman. It was crude. The tolerances were loose. The finish was rough. The components were not fitted with the loving precision that a German factory would have demanded. To your trained eye, it looked like what it was: a tank built quickly, cheaply, by people who did not care about elegance. And then you did something simple. You took a part off the first Sherman, a component, any component, and, out of professional curiosity, you tried to fit it onto the second Sherman. And it fitted, perfectly. First time. Without adjustment, without filing, without the work of a skilled fitter to make it seat correctly. The part from tank number 1 dropped straight into tank number 2 as though it had been made for it, because, in a sense that your own industry could not quite match, it had been. Now, to understand why this unsettled a German engineer, you have to understand what happened when you tried the same thing with two German tanks. It often did not work. Take a component off one Panther and try to fit it to another Panther, and there was a real chance it would not seat correctly without adjustment. Without a skilled fitter filing, shimming, and hand-working the part until it fitted that specific tank. Because German components, superbly made as they were frequently finished by hand, fitted to their individual machines by craftsmen, tuned to tolerances so fine that each assembly was, to a degree, unique. A part was not simply a part. It was this part, made to fit this tank, by this fitter. The German engineer had built tanks like fine watches, each one assembled and adjusted by a craftsman, until every piece seated perfectly against every other piece. And the result was a magnificent machine, and a machine whose broken parts could not simply be swapped for new ones, because the new one would have to be hand-fitted all over again. The American engineer had built tanks like a printing press builds pages. 10,000 tanks, every part on every one of them identical to the same part on all the others, every component swappable with every other, no hand-fitting anywhere in the entire process. To the German, the American approach looked crude, and in a sense it was, but it contained a secret that the German, trapped in his own tradition of excellence, was slow to grasp, and that was quietly the most important industrial fact of the entire war. The Sherman's parts were interchangeable, and interchangeability is not a minor manufacturing convenience. It is a form of immortality. This is not a story about tanks. This is a forensic audit of the deepest secret behind every single episode of this channel, the American system of manufacturing, the idea of the interchangeable part, and of why an army whose machines were made of identical, swappable pieces could keep those machines alive in a way that an army of hand-built masterpieces never could. Part 1. The German Calculus. To understand what the Germans got wrong, you first have to understand that it flowed directly from what they got right, because that is the tragedy at the heart of this whole story. German manufacturing was built on a foundation of craftsmanship. The German industrial tradition prized the skilled worker, the master craftsman, the Meister, the man who had served a long apprenticeship and could make things to a standard of precision and quality that was, genuinely, the envy of the world. German engineering excellence was real, and it was deep, and it was cultural. It went back centuries, to the guilds, to a whole social system built around the transmission of craft skill from master to apprentice. And this tradition produced spectacular results: German optical instruments, German machine tools, German precision engineering. These were, and in many cases still are, among the best in the world. When you wanted something made superbly, made to fit perfectly, made to last, made with an elegance that was almost an expression of national character, you wanted it made in Germany. But this tradition carried an assumption inside it, and the assumption became a trap. The assumption was that quality means precision of fit, achieved by skill. that the mark of a well-made machine is that every part is fitted, precisely and individually, to every other part, snugly, tightly, perfectly, by a craftsman who takes pride in the seating of each component. This is a beautiful ideal, and for a handmade object it is the correct ideal. A fine watch, a fine rifle, a fine optical instrument, made this way, is a superior object. And it is catastrophic for mass production in wartime, for two connected reasons. The first is that hand-fitting does not scale. Every component that must be individually fitted by a skilled worker is a bottleneck, because skilled workers are scarce and slow, and the whole rate of production is limited by how fast they can hand-fit. An industry built on craftsmanship cannot suddenly produce 100,000 of anything, because it does not have 100,000 master craftsmen, and it cannot create them quickly, because creating one takes years of apprenticeship. And the second reason is the one the engineer discovered in the workshop, and it is the deeper one. When parts are hand-fitted to individual machines, they are not interchangeable. A part made for one tank will not simply drop into another, and that means that in the field, when a tank breaks, you cannot simply grab a spare part and swap it in. The spare part will not fit, not without a skilled fitter, and the tools, and the time, to hand-work it into place. Which means field repair becomes slow, difficult, and dependent on scarce skilled men, exactly the resource an army in the field has least of. So the German tank, magnificent and precise, was also, by the very qualities that made it magnificent, hard to repair. We saw the consequences of this in an earlier audit, the story of the recovery vehicles and the tanks that could not be brought back. Now we see the root of it. The German tank was hard to repair, not only because of its size and complexity, but because at the most fundamental level, its parts were not designed to be swapped. It was a masterpiece, and a masterpiece is a thing you cannot easily fix, because every piece of it is unique to the whole. And there is a deeper cultural layer beneath even this, which is that the German system did not fully want to abandon craftsmanship, because craftsmanship was bound up with German identity and German pride. To build things the crude American way, loose, rough, interchangeable, unfitted, felt like a lowering of standards, an abandonment of the very excellence that made German engineering German. There was a genuine cultural resistance to the idea that worse-fitting parts could produce a better war machine, because it inverted everything the tradition valued. The German engineer looking at the crude Sherman felt, on some level, contempt. And the contempt was itself part of the trap, because it prevented him from seeing that the crudeness was not a failure of engineering, but a different and, for this purpose, superior philosophy of it. That is the German calculus. A magnificent tradition of craftsmanship that produced superbly made, precisely fitted, individually assembled machines that could not be mass-produced fast enough and could not be repaired easily in the field because their excellence lay precisely in the hand-fitting that made their parts unique and unswappable, and a cultural pride so deep that it could not fully accept that the crude, loose, interchangeable enemy machine was, for the purposes of a long industrial war, the better idea. Now let us look at where the American idea came from, because it did not come from the war. It came from a century earlier, and it is one of the most important ideas in the history of the modern world. Part 2. The American Answer. The interchangeable part is such a familiar idea today that it is almost invisible, and we have to work to see how radical it once was. But it was radical, and it was, to a remarkable degree, an American obsession from the very beginning of American industry. The idea has roots in several countries, and French thinkers and gunmakers explored it early. But it was in the United States, in the first half of the 19th century, that it became a national manufacturing philosophy so distinctive that the rest of the world gave it a name, the American system of manufacturing. The core idea is simple to state and was fantastically difficult to achieve. Instead of having skilled craftsmen make complete objects one at a time, each slightly different, you design the object as a set of standardized parts, and you build machines and jigs and gauges that allow relatively unskilled workers to produce those parts to a consistent standard, so consistent that any part will fit any assembly. You take a random barrel and a random lock and a random stock, and they assemble into a working musket, without a single skilled fitter touching them. The early attempts to achieve this, in American armories in the early 19th century, were the crucible in which the whole system was forged. It was enormously hard. It required precision machine tools, standardized gauges to measure every part against a master standard, and a completely new way of organizing production around the part rather than around the craftsman. But the Americans pursued it with a persistence that verged on the ideological because it fitted the American situation perfectly. And here is why it fitted America and not Europe, because this is the deep reason the two traditions diverged. Europe, and Germany especially, had an abundance of skilled craftsmen and a deep guild tradition. It made sense to build an industry around that abundance, around the master craftsman, the apprentice, the hand-fitted quality object. The skilled worker was the resource you had, so you built your system to exploit him. America had the opposite situation. Skilled craftsmen were scarce in the young republic, and labor of all kinds was expensive because land was cheap and men could always go west and farm. What America needed was a way to produce manufactured goods without depending on a large pool of skilled craftsmen it did not have. And the interchangeable part system was exactly that. A way to make complex goods using machines and unskilled labor, with the skill built into the tooling and the gauges rather than residing in the worker's hands. So the two traditions were each a rational response to each nation's situation. Germany, rich in craftsmen, built an industry of craftsmanship. America, poor in craftsmen and rich in space and ambition, built an industry of interchangeable parts and machine tooling. For a century, both worked. And then came a war that was, at bottom, a contest of mass production and field repair. And one of those two traditions turned out to be shaped, as if by prophecy, for exactly that contest. By the time of the Second World War, the American system of manufacturing had had a century to mature, and it had spread from muskets to everything. Sewing machines, typewriters, bicycles, and above all automobiles, the American automobile industry was the supreme expression of interchangeable part mass production, the assembly line being simply the interchangeable part taken to its logical conclusion, with standardized components flowing together into standardized products at enormous speed. And when America went to war, it built its war machines the same way. The Sherman tank was designed, from the start, for mass production by interchangeable parts. So was the Jeep, the truck, the aircraft, the rifle. Every one of them was conceived not as a masterpiece to be individually assembled, but as a design to be reproduced identically, tens of thousands of times, from standardized components that were interchangeable across every unit ever made. And this gave the American war machine two colossal advantages, and they are the two advantages that decide long industrial wars. The first is production speed. Because nothing had to be hand-fitted, production could be scaled to the astronomical numbers we have discussed throughout this series. You do not build 50,000 Shermans by hand-fitting. You build them by stamping out identical parts and assembling them without adjustment, at a rate that a craft industry cannot approach. The second is the one the German engineer discovered in the workshop, and it is the one that matters most for our story. Field repairability. Because every part was interchangeable, a broken Sherman could be repaired by simply removing the broken part and bolting on an identical replacement from a supply depot, or from another wrecked Sherman, or from a crate of spares, by an ordinary mechanic, with ordinary tools, in the field, in hours. No skilled fitter. No hand-working. No factory. The immortality of the machine was built into the sameness of its parts. Part 3. The River of Steel. The consequences of interchangeability ripple through the entire American war effort. And once you see the pattern, you see it everywhere. Because it is the pattern. Consider what interchangeability does to the supply chain. If every part is identical across every machine, then you can stockpile spare parts centrally, in enormous quantities, and ship them anywhere, confident that they will fit whatever machine needs them. A single crate of a given component serves every tank of that type in the entire theater. The spare part becomes, itself, a kind of interchangeable unit in a vast logistical system. And we have already seen that system in action. The river of trucks carrying not just fuel and ammunition, but the endless swappable parts that kept the machines alive. Consider what it does to maintenance. An American mechanic did not need to understand the whole machine as a unique artifact. He needed to know which part had failed and to replace it with an identical part. This is a fundamentally easier task, one that could be taught to ordinary men quickly, at scale, the same lifting of the many to reliable competence that we found in the training system, applied now to maintenance. You did not need a master mechanic who understood the soul of each individual tank. You needed a competent one who could identify a failed component and swap it, and America could produce those by the 100,000. Consider what it does to the whole recovery and repair system we examined earlier. The reason a knocked-out Sherman could be dragged in, stripped for parts, and those parts used to resurrect other Shermans, is that the parts were interchangeable. Cannibalization, taking parts from dead machines to keep living ones running, only works if the parts are the same. The American ability to keep an astonishing proportion of its tanks running at any given time rested directly on interchangeability. The German inability to do the same rested directly on hand-fitting. The recovery vehicles were the visible mechanism, but interchangeability was the invisible principle that made recovery worth doing. And consider what it does across different machines entirely. American designers deliberately shared components across different vehicles, the same engine family, the same wheels, the same small parts appearing in multiple different machines. This meant the supply and repair system was simplified even further, and it meant that the industrial base could be flexible, shifting production between products that shared components. It was interchangeability not just within a machine type, but across the whole ecosystem of American war machines. Now set this against the German reality, which was the mirror image at every point. German production was slowed by hand-fitting. German spare parts supply was complicated by the fact that parts were not reliably interchangeable, so you could not simply stockpile and ship a universal component. German field repair was hampered by the need for skilled fitters. German cannibalization was harder because parts from one machine might not fit another. And the famous German proliferation of types, many different vehicles, many different variants, produced in relatively small numbers each, multiplied the problem enormously because it meant a chaos of different, non-interchangeable parts, a logistical nightmare of thousands of distinct components, exactly the opposite of the American ideal of few types, many units, all parts the same. The German war machine was a collection of masterpieces, each superb, each unique, each hard to feed and hard to fix. The American war machine was an ocean of identical units, each one individually inferior, all of them endlessly repairable, infinitely supplied, and collectively unstoppable. The Germans built the better tank. The Americans built the better system for having tanks. And in a long war, having tanks, month after month, in working order, is the only thing that counts. Part 4. The German realization. The Germans came to understand the interchangeability problem, and their understanding is written into their own increasingly desperate attempts to address it late in the war. There was, in the later years, a real German push towards simplification and standardization, an effort driven by the reality of the production crisis to reduce the number of types, to standardize components, to move towards something more like the American model of mass production. The men running German war production understood, by then, that the proliferation of handcrafted types was strangling them, and they tried to rationalize it. But you cannot retool an entire industrial culture in the middle of a losing war. The American advantage was the product of a century of development, a century of building the machine tools, training the workforce in a different philosophy, developing the gauging systems, accumulating the deep institutional knowledge of how to do interchangeable mass production well. Germany could not acquire all of that in 2 or 3 desperate years while being bombed. It could issue directives about standardization, and it did, and they helped at the margins. But the fundamental culture and capability of interchangeable mass production could not be conjured into existence by decree. And there was the cultural resistance we discussed, which never fully went away. The German engineering mind, trained to value precision and fit and craftsmanship, found it genuinely difficult to embrace the deliberate crudeness, the loose tolerances, the good-enough philosophy that interchangeable mass production requires. The instinct to make each thing beautifully, to fit each part precisely, ran too deep. It was the source of German excellence, and it was the source of German inflexibility, and the two could not be separated. And so the most perceptive German observers arrived at a realization that was, in its way, more profound than any single point about tanks or parts. They realized that they had been beaten not by better engineering, but by a better philosophy of engineering, that the Americans had understood something about the relationship between quality and quantity, between precision and reproducibility, between the masterpiece and the system, that the German tradition, for all its brilliance, had missed. The Americans had grasped that in a long industrial war, a machine's most important quality is not how well it is made, but how easily it can be made again, and repaired, and kept running. And that is a quality that comes not from craftsmanship, but from its deliberate abandonment, from the disciplined, almost counterintuitive choice to make each individual thing slightly worse, so that all the things together can be made better. The German engineer, looking at the crude Sherman whose parts all fitted each other, was looking at the physical embodiment of that choice. And the deepest ones understood, at last, that the crudeness they had felt contempt for was not inferiority. It was a superior answer to the actual question the war was asking. A question not about how good a single tank could be, but about how a nation could have the most working tanks, in the most places, for the longest time. They had lost, in other words, to an idea that was 100 years old, that had been sitting in plain sight the whole time, and that they had been culturally incapable of taking seriously until it was much too late. If your father, your grandfather, or your uncle worked as a mechanic in the war, in an ordnance company, a maintenance battalion, a motor pool, keeping the machines running by swapping the identical parts that the American system made possible, I would be grateful to hear his name and his unit in the comments. The men who kept the equipment running are almost never remembered, because keeping a tank running is not a battle and wins no medals. But an army is only as strong as the fraction of its machines that actually work on any given morning, and those men are the reason that fraction was so high. They are mostly gone now. What remains are the stories their families carry. Those stories belong in the record. Part 5. The Verdict. 1945. The war ends, and the interchangeable part, having helped win it, goes on to remake the entire world. The American system of manufacturing, proven and perfected under the pressure of war, became the foundation of the post-war consumer economy. The mass production of interchangeable part goods, cars, appliances, electronics, everything, created the prosperity of the second half of the 20th century. The very philosophy that built the Sherman, built the world we live in now. It is one of those cases, which we keep finding in this series, where the industrial capability developed for war turned out to be the seed of an entire way of life. So here is the verdict. The German engineer who took a part off one Sherman and found that it fitted another perfectly was looking at something that his whole magnificent tradition had prevented him from valuing: the deliberate sacrifice of individual perfection for collective reproducibility. He came from a culture that made each thing as well as it possibly could be made. The Americans came from a culture that made each thing just well enough and identical so that it could be made 100,000 times and repaired forever. And in a war of years, fought across a continent, decided by how many machines were running on any given day, the second philosophy crushed the first. Not because the American engineers were better, they were not, but because they had inherited a 100-year-old idea that was shaped, as if by destiny, for exactly this kind of war. The Germans built each tank like a watch, perfectly fitted, individually assembled, magnificent and unique, and mortal. The Americans built 10,000 tanks like one tank, every part the same, every part swappable, no craftsman required and none missed. And a machine built that way does not really die, because its parts are immortal even when the machine is destroyed, living on in the next machine, and the next, an endless resurrection of identical components that no amount of German excellence could ever match. The Germans could afford to make each machine perfect. The Americans could afford to make every machine the same, and the same, it turned out, was worth far more than perfect. If this forensic audit gave you something to think about, hit the like button. It keeps this channel visible to the people who want the history the way it actually happened. Subscribe if you want the next audit, because there are more of these, more systems, more decisions, More of the invisible, unglamorous machinery that decided who won and who came home. And remember this about the idea itself. Nobody makes a film about a gauge, the humble measuring tool, the master standard, against which every part was checked so that it would match every other part. There is no monument to the men who, over a century, worked out how to make 10,000 identical things so that any one would fit any other, so that a mechanic in a muddy field in France could take a part off a dead tank and give it to a living one and send it back into the fight. Those men were not soldiers, and most of them were long dead before the war they helped win. They were machinists and toolmakers and engineers, working out, decade by decade, how to make things the same. And in doing so, they built, without knowing it, one of the most powerful weapons of the 20th century. Not a gun, not a bomb, but an idea. That identical is stronger than perfect, that the swappable part outlives the flawless one, and that a nation which masters the boring miracle of making things exactly alike can outlast any enemy, however brilliant, who insists on making each thing beautifully and alone. Mostly, that idea is why the tanks kept running. They deserve to be remembered, the toolmakers, the machinists, the mechanics, by the humble, world-changing truth they served, that in the end, the part that fits every machine is worth more than the part that fits one machine perfectly, and that sameness, patiently mastered, is a kind of immortality.